So in the instructions, so we are going to do some puzzles. So the make puzzle. So first create a board with 2 dimensions and add n digit between 1 and 2 to the board. So is actually shown here. So first we create a board, then we assign a random value to fill up the 1 over n% of the puzzles. And then we will create a list, then a row set, and also column set and region set. So it's over this session. So this session is the row set sessions. Here, this session is the column set sessions, and this is the region set sessions. And then at the end, we will represent the puzzle as a dictionary, which have these 4 keys over here. So we have these 4 keys over here, and this is in a dictionary format. So we fulfill the first requirement, and then the second requirement, get square. So we will need to return information about the square at the row and column positions. So and then we will represent it in the dictionary. So first we will determine the region. What is the region row index? So we just take the mat flow, then use row divide by the the size of the rect set. So this is an example. If we use get square puzzle with a 9 to 9 puzzles, and then 1 and 8, then 1 divided by 3. So and then we take the flow, it will be at the index of 0. Okay, so after we have all this information, we will put the information into the dictionary in this format again, comprising like 4 keys, 1, 2, 3, 4, 4 keys, and then we return it. Okay, and then here we fulfill the second requirements. The third requirements on the move. So we will use the get square functions. Get square function. Here we use the get square functions, and then we will want to check if the square is empty and new value can be placed there without breaking the rules. So first we will check if the value is at 0, and then here this portion is checking whether it will break the puzzle's rule. So the puzzle's rule stated that your row should not have the duplicate value, your column also wouldn't have double the similar value, and also in the region itself. And then if it is not breaking the rule, so you can add a new value in the set and return true, otherwise return false. So yes, if you meet this condition, so you will be add into all these keys. So the first key, the second key, the third key, and the fourth key on the region, and then we return true. Else you will return false. So we fulfill the third requirements. The number 4 requirements, fill puzzles. So we are going to use the move functions to fill puzzle with random digit, random positions. So we have we would use a loop, and then here is the random positions, and then here is the random values. Okay, so and then you may stop filling when the number of 10 is n power to 4 and 75%, which is in this loop over here. And then fulfill the number 4, and then in the main we need to create initial puzzle, print it, and then yeah, it should fill the puzzle board. So let's run a 16 times 16. So I will just run this, and let's look at the results. So from the result, so we can see that so this is the initial puzzle. So let's run the final puzzles again. Let me run. Okay, so this is your initial puzzle. So initial puzzle, you have the board, the row set, the column set, and the region set, and then your initial board will be printed like this. So some of them already filtered out, will be filled out, and then your final puzzle also a dictionary form, and then in the board form. So you can see here like 75% of the board already filled up, and the number of attempts is 176 over here. And then let's check if it meet all the conditions. So let's check on the rows. So first row doesn't have any duplicated one, and then let's pick a random one, also doesn't have a duplicated one. Let's check on the columns. Let random column here, we done, yes, still we doesn't have any duplicated numbers. And let's check on the region over here. So we have 1 2 3, I think 4 6 5 6, yeah, we doesn't have any duplications. So um lastly, it took some second to run 70% of the 10 by 100 by 100. So we can just change the value here to let it run 100 iterations. Okay, so it took quite a while, but actually it's quite worth it. So yeah, 100 by 100 it run with like 15 seconds. It depends on the your performance of the laptop, of course. And then lastly, what are the expected time complexity? And then yeah, this is the time complexity. So the move function will take like O1, and then the worst case scenario will take around O with the n power to the 2. And that's it. And thank you.